There's one final data structure that I want to discuss that is sequential based, and it's a little disingenuous to say it's sequential based because it's not entirely sequential based or index based because you can't access arbitrary indices, but there is an ordering to the elements that is significant, and that is something that is called a priority queue. Now, fortunately, a priority queue is fairly straightforward. I mean, it's a queue where elements have a priority. So, I mean, that's as simple as it seems. So, the way that a priority queue works is that so let's say that we're going to create a priority queue, and we can do that in Java over here. So, the way to create one is we're going to create something that is a queue, and let's just say it stores integers for now. We'll call it pq equals new priority queue. Okay? The way that a priority queue works is that when we add elements to it, like let's say we add the value 42, and then let's say we add the value 8, and let's say we add the value 21. The way that a priority queue works is that it will order its elements based on some level of priority that we give to it. Okay? So the thing is, we're not giving a priority to the elements right now. We're just giving it numbers. So what exactly is it going to do? Well, the priority of elements, if we don't specify a way of giving priority, is the natural ordering of the elements. And we've talked about this before with tree sets and tree maps. So what this means is if we traverse over the priority queue, or traverse through the priority queue, then we're going to get these elements, or we're going to view these elements with respect to the natural ordering of integers, which means that we would see 8, and then 21, and then 42. Now, the way a priority queue works is perhaps a little bit backwards, because you might think that 42 has the highest priority because it's the highest integer, or it's the largest integer. But that's not how it works. The way it works is that it depends on the ordering of the elements. So because 8 comes before 21 and 21 comes before 42, the ordering in the priority queue will be 8, 21, 42. Now, the way to view these elements, you might think, is to use a for loop. You know, like for int x in pq, then system out println x. Okay. Okay. Not what I want to do. There we go. This is what happens when I do a find and replace. Okay. So if we do it if we try to traverse over the elements of the priority queue with a for loop, with an enhanced for loop, then we're going to see something that looks a little bit awkward. We have 8, 42, 21. That doesn't meet the definition that I just said, and indeed that's correct. Because the only way that an ordering for a priority queue is guaranteed is when we are removing elements from the priority queue. So the ordering of the elements, or the priority that we use, is only guaranteed when we're trying to process the elements of the priority queue. So how exactly do we do that? Well, one way is to just continuously loop over the priority queue until it's empty. And for every iteration of the loop, we just pull something from the queue. So for example, we can do pq.pull, and if we do it this way, then we'll continue looping until the priority queue is empty, and this will obey the ordering that we expect. So we'll get 8, 21, 42, and indeed, that's what we get. Okay? So this seemed a little bit awkward because it just seems like that all we have here is a tree set. Well, for one thing, or even like a tree map. Well, that's not entirely correct. I mean, in fact, it's really not correct because priority queues can have duplicates. So let's say we have the value 8. If we add a second 8, then that's perfectly fine. We can also remove things directly from the priority queue. unlike a tree set or a tree map. And by directly, I mean that you can't say while while a tree set is not empty, pull the first thing from the set, because there is no first thing from the set. There is nothing that's sort of on top of the priority queue. There's nothing that has a highest priority, because there's no ordering to the elements. With a priority queue, there is an ordering to the elements. And under the hood, it's processing these elements and it's storing them in such a way that when we call pq.poll, it will always return the element with the highest priority. And by highest priority, I mean the next thing that will be removed from the priority queue. Okay? And again, with integers, that would be least to greatest, so ascending order. For strings, that would be lexicographical ordering. So for example, if we did something like, let's say let's do the name Josh, the name Jack, the name Joey, and the name Jane. So because we know how strings are ordered, this would go, let's see, we have J-A-C-K, so Jack would be the highest priority. The second highest priority would be Jane. The third highest priority would be Joey, and the fourth highest priority would be Josh. So that's what we get. So the thing that makes priority queues interesting is like a couple of neat tricks that we can do with them, and we'll talk about those in a future video. But the main thing that we like priority queue, or the reason why we like priority queues, is because we can specify different ways of comparing elements. Okay? And in one of the next videos, I'll show you an explicit example of defining a comparator, passing it to a priority queue, and showing you how that affects the ordering of the elements in the priority queue.